Welcome to this statistics lesson. Nathaniel's here with me, and we're going to talk about how many ways there are to perform a different task or to make a different choice. So I have a question for you. Let's say this is an Arizona license plate, and every Arizona license plate has 3 letters and 3 numbers, obviously one-digit numbers. How many ways are there to arrange a license plate? How many possible license plates could we have? In order to talk about that, we're going to talk about tree diagrams. And you guys need to make sure you're paying good attention so that you can make your own tree diagram. So Nathaniel, give us an example.
All right, so if in your wardrobe you have 3 shirts, 4 ties, and 2 pairs of pants, how many different outfits could you make from this? Well, if you have 3 shirts, that's 1, 2, 3 different options you have to start off with. But with each of those shirts, you could pair 4 ties. So now you have 4 times 3 options. And then with each of those combinations, you could pair 2 different pairs of pants, meaning that you have 3 times 4 times 2 options. So with each choice, you see the lines. So you have
each choice, the number of choices is represented by the branches.
Thank you.
Okay, so we call this the fundamental principle of counting, which is what our lesson is about today. And the fundamental principle of counting says that if one step can be performed m ways, m is just some number, a variable, and another step can be performed n ways, then the 2-step process can be performed m times n ways. So the number of ways that the first thing can be done times the number of ways that the second thing could be done would give you the number of ways that they could be done in a row.
So, let's put this concept to the test. You're at a restaurant and you have this menu. You can choose any of these main courses, and any of these sides, and any of these drinks. So, of the main courses, you can choose spaghetti, lasagna, steak, and of the sides, you can choose baked potato, broccoli, so on. And how many different meal combinations could you have? Well, how many different main meals do you have? You have 3. And then the sides, you have 5. Oh, sorry. What? Oh.
Go ahead and pause it and try it on your own.
Go ahead and pause and try on your own. All right, so how many different main meals options? You have 3 main meals, 5 sides, and 3 drinks. So 3 times 5 times 3 is 45. 45 different meal options you have from this menu.
That's great. So many options. Such a small menu. All right, next thing we're going to look at is the number of combinations for a lock. So let's say you get this combination lock. It's one of those ones with the rotating ones. And you need to put a combination on it, and you're like, well, how hard would it be for somebody to guess? How many possible options could there possibly be? It's just 4 numbers. Well, let's think about it. How many options are there for the first number? How many numbers are there from 0 to 9? Most people say 9, but I know you said 10 because you're smart. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits. Okay, so there are 10 options for the first one. Could we have the same digit twice? Sure, there are 10 options for the second one. I want you to think about how many possible combinations there would be. Pause the video, figure it out. All right, hopefully you came up with the number 10,000. There are 10,000 options for that combination.
So, let's try this again. Using A, B, and C instead of a combination. How many different words or 3-letter combinations could you come up with out of just A, B, and C? So your first choice is A, B, or C. And then your second choice would be to repeat A, to go to B, or to go to C. Same with the other ones. So you have this part of the tree where you can choose the second letter. And then you have those same 3 letters as options again. And 3 times 3 times 3, 27. So you have 27 different letter combinations between A, B, and C.
All right, but what if you can't repeat the letters? So we're going to make, how many words can we make with the letters K, A, T, and E? Hi, Kate. But you can't repeat letters. So we can't have K, 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 K for many reasons. All right, now, so what's our first letter we can choose? Well, we can choose to put K, A, T, or E first. But after that, how many letters can we choose? Well, after K, we can't choose K again because we can't use the same letter twice. So how many combinations are there? Well, now we could choose A, T, or E. I want you to pause the video, finish this tree diagram, finish the tree diagram and figure out how many words you could make with the letters K, A, T, and E. Remember, they don't have to actually make real words. All right, hopefully you finished that up and you saw that for the first one we had 4 options, but then for our second choice we now only had 3 options because we already used one of the letters. And then for the third choice we had just 2 options left because we already used 2 of the letters, and last we only had 1 letter left that we hadn't used. So we'd have to do 4 choices times 3 choices times 2 choices times 1 choice, which is 24 words. All right, moving back to our license plate. Okay, Nathaniel, how many options are there for that first letter?
Well, how many letters are there in the alphabet? 26.
And for the second letter?
26.
And third letter?
And 26.
All right, how many options for the first digit?
10.
10, because 0 through 9. All right, I want you to pause the video, see if you can come up with the number of license plate. Hint, there's a lot. All right, Nathaniel, if we do 26 times 26 times 26 times 10 times 10 times 10, how many options for the license plate are there?
17,576,000.
All right,
a lot of people.
Hopefully you learned a lot about the fundamental principle of counting today, which says that if one step can be performed M ways and another step can be performed N ways, then the 2-step process can be performed M times N ways. Make sure you know how to make tree diagrams to illustrate choices, and have fun with your homework. We will see you in the next lesson.